I'm pretty cool like that. All right. Okay, so, well, let me find the notes that I've already done, because those have the answers on them. Okay, so yesterday we talked about logarithms. Hopefully you got the notes if you weren't here. Otherwise, today might be a bit confusing. Maybe not, though. But you know that logarithms and exponentials are inverses. That's the nice word that we're going to use there. And in math, we use the word inverse to talk about anything that's the opposite or that undoes the other thing. Okay. And this helps us graph because, and I think we might have talked about this a little bit last semester. I don't know what exactly I said, but this helps us graph because we can graph an exponential function. We know how to do that. We can just plug it into the calculator and complete the table, right? So we can graph the exponential, and then, okay, let's think about this. If inverse means opposite, and I have a table of values, what do you think that I can do to graph the inverse? Switch what? Yeah, then you switch the x and the y. Okay. So you're going to switch the x and y values. So I'm going to do it in two different colors. I'll do blue and, well, that's too hard to tell the difference of on a computer screen. I'll do red and purple. So with your graphing calculator, you don't know how to put in a different base, right? I haven't taught you that. And some calculators won't have that option. So what we're going to do, okay, the inverse of log base 3, because this function right here, is going to be represented by this bottom table. This top table, we're going to call g of x the inverse. And the inverse of log base 3 to the x is going to be 3 to the x. Right? The base stays the base. Remember that from yesterday? Hopefully you watched that video. Okay? So that is the inverse of log base 3 of x. Okay? You'll start seeing a pattern as you do more. So what we're going to do is in your calculator, go to y equals, clear out whatever nonsense Algebra 1 put in there from yesterday. And we're going to put in 3 to the power of x. And then go to the table. Okay? And I say to my Algebra 1 kids all the time, I don't like decimals, but for graphing and completing tables, I'm okay if we want to fill in the table with this. So -2 is 0.1. I'm just going to round. 0 is 1. 1 is 3. 2 is 9. You could have done fractions, by the way. You could have done 1 over 9 and then 1 over 3. That's fine. Wow. Hello. Hey, thanks. Okay, so let's graph this. If we go to -2 and then 0.1, -1.3, 0 and 1, 1 and 3, 2 and 9. We do connect the dots here. Okay, so that's, oh, you can't see it, I'm so sorry. That's what the graph of the inverse looks like. Okay? And now that we have the graph of the inverse, you can just switch the x's and the y's. So x was -2, so now that's the y. And the y becomes the x. It's like a mirror image. And if you look, the way that I've set up the table, it kind of looks like we just mirrored it. That's pretty cool, right? You're welcome. So if x is 0.1, f of x is -2. 0.3 is -1. 1 is 0. 3 is 1. And then 9 is 2. And then you connect the dots. It's kind of a not great graph I got there, but that's okay. And if you remember, I don't even remember what, this might have been a chapter 5 thing. But if a graph is an inverse, then it's going to be a reflection over the line y equals x. Do you remember that? And so that's what it looks like. So you know that you're right if that happens. Okay. So the graph that they actually asked you for was this one right here. That is the red one. Okay, we just used the purple one to get us there. So on Big Ideas, make sure that you graph the correct one. Okay. Beautiful. Why don't you try the next one? And I'm going to show you something cool. Here's your inverse, by the way, if you didn't make it there. Oh my goodness. I can't wait to use this in real life someday. Oh yeah, how did I forget? You're skiing down a slope. That would actually be a fun slope to ski down. So you might think that you're wrong because your graphs have crossed. But that's okay. That line of reflection, again, is right here. Yay, reflections. Wasn't that your favorite part of geometry? Yeah, I loved it. Who said that? Anything except proofs? Yeah. Hey, Terrell, I highly recommend you don't major in math. Because, can I tell you something? My advanced calculus final, 11 proofs. And not like proofs like 2-column proofs like you guys get. No. Like 8.5 by 11 sheets, like each one was. So, what is the point of that?
It's already proved.
Yeah, it was a good time. Okay, can I show you something that's going to make you really mad? Go to your calculator. I mean, it might not make you mad. You're just going to be like, why didn't we do this before? Yeah. If you hit the math button right here, underneath the green alpha button, if you hit math, and then if you arrow down for quite a while, You get to something that says log base. If you click enter, would you look at that? So now, if you're ever asked to graph, just use that. I mean, you can graph the exponential and then switch and find the inverse. That's fine. But, you know, that's a lot of work, so. I'm sorry. I have to teach it to you this way because the poor unfortunate souls at other schools that don't have graphing calculators, that's how they graph logarithms. Yeah, you get really creative and stuff when you don't get all the cool things that you guys get here at PHS. So, you're welcome. Go Pirates. All right, to the back. To the back. All right, so here's some fun things to learn. By the definition of a logarithm, okay, if I give you something like g of x is equal to log base b of x, so any base is fine. G of x is the inverse of f of x equals b to the power of x. That's what we just talked about. Okay, the base stays the base. Those are inverses. Okay. So that means if they're inverses, do you remember what happened? I think on the chapter 5 test, I asked you, like, if you composed a function and you took some function and you plugged its inverse in for x, what happened? Do you remember? If you if you took the inverse and you plugged it into the function, what happened? It doesn't equal 1.
Oh, x.
X. You get x. You remember that? That was something that you did on the test. Some of you passed that part. I don't know. So what that basically means, if we have log base b, that's coming from here, okay, of x, but we're going to plug in the inverse for x, and the inverse is b to the power of x, okay? So I'm taking its inverse and plugging it into the function. That means that we have to get x back out. That's the definition of an inverse, okay? And the same thing happens. If we have b to the power of x right here, so b to the x, but its inverse is log base b of x, then it must be x. That's the definition of an inverse. I'm not going to prove it. You're welcome. But I can if you're like just really gung-ho about some proofs. Come see me later. And I'll prepare for it. So tell me in advance that you're coming. Yeah. You want to see it? Okay. Great. I'm going to have to look at it. It's going to be a great time. Okay. So that means, here's what this means simply. Okay, because you're like, that's a whole lot of nothing. Let me explain. First of all, what's the base on a logarithm if you don't see one? It is 10. So you have 10 to the log. I'm just going to plug in base 10 right there just so we see it. You don't have to, but it's just kind of good to see. All that means, you guys, is that an exponential and a logarithm undo each other. And all you're left with is 4. That's all that top part is telling you. Okay. This is one of those cases where the math way is really confusing, but the number way is way simpler than what you thought. And the same thing here, except for the fact, do you see how the base of the logarithm and the base of the exponential have to be the same thing? Yeah, right here, that's not the case, right? Because it's 5 and 25. But could you rewrite 25 to have a base of 5? You could write it as 5 squared, right? So what if we wrote it as log base 5 of 5 squared, and then we still have the x out there, right? But then your awesome Algebra 1 teacher should have taught you that that's the same thing as this, right? You just multiply those exponents. Yay, Algebra 1. And now the bases are the same, right? A logarithm and an exponential undo each other. So you're left with 2x. Okay, great. Did I confuse you? Is that good? Jordan, that's the one you were asking me about yesterday, I think. Okay, this next part's going to pop up on your test. I'm just going to let you know. Also, I have a note in my notes that says the calculator is allowed, but you must show all of your work. So on something like this, I would need to see the process, like, because you could plug this straight into the calculator, right? Like, that's something you could do, but I need to see the logic of you understanding why it works. I will be clear on the test with the directions what that means, so you're not confused with that, okay? Okay, great. Here's why we care. We're going to find the inverse of f of x equals 6 to the power of x. Well, let's just use this rule that we just learned up here, right? If you've got an exponential, its inverse is just a logarithm with that same base. So we'll call the inverse, actually, we should technically use the notation, right? That's what we normally use for inverses. So the inverse is just going to be log base 6 of x. Take that for face value, dear children. Okay. Now, do you guys remember, how did you normally find inverses? If I didn't point blank tell you how to find an inverse, how did you do it? Like, I didn't give you the rule like I just did. You switch the x and the y, and then what? Okay, so let's do it for this one so that you see how that works, and then that's how we're going to solve b and c. So if we have y equals 6 to the power of x, we're going to switch x and y, right? And then we're going to use that BAY acronym to convert it. So you take the logarithm, the base stays the base, the answer comes next, and whatever's left is now your answer. Base, answer, exponent. Remember that? Great. And it's the same thing. So to me, I don't care how you do that one. This one is obviously way easier, but that only works if it's a simple exponential or logarithm. When you get to stuff like b, then things go crazy. Am I okay? Are we kind of picking up what I'm throwing down? It's kind of a weird idea. Okay. Okay, so on this one, switch x and y. By the way, the natural logarithm, what's the base on that again? E, right? Log base E. So I'm going to, let's see, I'm going to rewrite it as log base E. You don't have to, but this just kind of helps me visualize. Oh, that should have been a y. It just helps me kind of visualize. Okay. Now we have to get y by itself, and y is right here, and it's protected by a whole lot of stuff, right? You got those parentheses and the 3, but you've got this logarithm on the outside that we have to get rid of first. Well, how do you get rid of a logarithm? With an exponential, right? So here's what you're going to do. You're going to take everything, and you're going to raise it like this to create an exponential equation. The reason why I did that, let me back up. I knew that to get rid of a log base E, I needed an E as a base up here because that's what we learned up here. We knew that those could cross out and go away and you're left with the exponent. And that's what I wanted to be left with. I want to be left with this. So in order to get rid of that, I need to get rid of a log base E, and I do that with an exponential of E as a base. Okay, but what you do to one side of the equation, you have to do to the other, right? So that's why I have e to the x on the other side. Is that okay? feel like that was real confusing coming out of my mouth. Are we good? Okay. Now what you can do, that goes away, right? Because that's why we did it. That's the whole point of doing that. And now you're left with e to the power of x is equal to y plus 3. And now what? So just subtract 3. So e to the power of x minus 3 is equal to y. There's your inverse. That was fun. You have 2 more on yours, right? You have 1 more? Okay, we're going to do 2 more. Because I realized something later on in life last year. Okay. Oh, wait, no. Is this your last one? Yeah. Oh, great. Never mind then. I printed it. Okay, so something I like to get in my head before I even start is it's an exponential, so our inverse is going to have a log in it. That's just good to know going into it. And if it has a logarithm and there's an e here, that means we're going to end with a natural logarithm because that's the base. Okay, so just going into it, that's what I know. So I switch x and y. And y is in an exponent. And in order to solve for things that are in an exponent, you need a logarithm, right? So here's what you can do. There are 2 different routes. Let's take the easy way first. Do you remember how I told you up here that this right here was the inverse of that? Well, you can just then go through and say, okay, that's great. The log base e of x is equal to 3y. That's just using that rule that I used up top. Sorry, it's kind of hard to see with the lighting. And then I don't really like log base e, so I'm just gonna say the natural log of x. Like that. And then what? Yeah, divide by 3. Divide by 3, divide by 3, and you will keep it the natural log of x over 3 equals y. Okay. Kind of. Like you'll give it a shot on some practice problems and maybe have a few questions. The good thing is that tomorrow, or you won't see me tomorrow, Thursday is a complete work day. So if something pops up on big ideas that's confusing, then we can talk about it. I will also have a quiz review for you when you walk in the class. And for those of you that weren't in my class last semester, well, here, I'm gonna end.